Today is Friday, August 26th, 2022. It is also day 404 of data science. And today I'm going to basically take one of the Khan Academy problems for normal distributions, and I'm going to take the context of it. So, for example, the context in here is a set of average city temperatures in May are normally distributed with the mean of that and a standard deviation of that. And so, what I'm going to do is I'm going to create a normal distribution, and then I'm going to sample from that normal distribution, and I'm going to basically just use that normal distribution to solve this question from scratch. And so the use case for this would be like, let's say you're a teacher and you're teaching like a Python class, and like, I don't know, like a data analytic Python class, and you want your students to answer this question given a normal distribution, like just a data frame, instead of already having the mean and standard deviation, you want them to like figure that out by themselves using like pandas methods and stuff. This would be the use case for that, like creating just a sample from that normal distribution. So you could use that distribution to have your students solve this question by getting these things from like by themselves instead of, being told that the mean and standard deviation is like 20.66 and 2 degrees Celsius. So the first thing would be to import NumPy as NP. All right, so to get the values of the sample, I would just create a variable called values and then do np.random because I want a random sample from the normal distribution. And so this takes in three parameters. It takes in the log, it takes in the scale, and it takes in the size. So the log is your mean. So I'm going to set up my variables here. So mean, I'm going to use again the context of the problem, so 20.66. And then the standard deviation, I'm going to use 2. So log, again, is your mean, so I just pass in that variable there. The scale is the standard deviation, and the way that I remember is S and S, right? So scale goes with the standard deviation because they both start with S's and whatever's left is the mean. And then finally the size is the size or like more of like the format that you want your output to be. So np.random.normal returns an array of just a random numbers. And so you can specify the amount of numbers that you want to be returned. So I could do like 500. So it's going to return to me a one-dimensional array of 500 random values from this normal distribution given the mean and the standard deviation. Um, but if I want, actually, let me actually do that and see what it outputs. So you can clearly see this is what it looks like. So right now, this is an array of 500 random numbers from the normal distribution, given again the mean and standard deviation. But if I want to, like, let's do 500, but then I want maybe two random samples of 500, then I'm going to get a two-dimensional array with 500, well, and a total of 1,000 random values. So there's like one column and another column, and then just 500 rows. So it's like the format is like rows, the amount of rows that you want, and then the amount of columns that you want. So this is just in case maybe you want to do like two random samples. If you want to do three random samples, you could also do that and run that, and you'll get three, what do you call them, columns, and then 500 rows or 500 random values in each column. But for me, I'm just going to leave it as 500 to get a one-dimensional array because when using pandas, you need to have one-dimensional arrays just to kind of just have it work. So I'm going to import pandas as PD, and this part is basically just converting this value into a PD series, or essentially just having it be a pandas, or inside a pandas data frame. So I'm going to do df for data frame, and then pd dot data frame, and then, whoops, this takes in a dictionary. The first value is the name of your column, so I could do like the context actually is average city temperatures in May. So I could be like average city temperatures, temps in May. And then the second value would actually be the values that you want. So that would be values here. All right. And then running that, if I do df and I run that, I'll be able to see it now in a pandas data frame, which is really, really cool. So again, I have 500 random values from a normal distribution. And so now this data frame is basically representative of this problem. So like instead of now having your student like start from here with like, just knowing the mean and standard deviation, you can have them start with this data frame and then be like, okay, find the mean, find the standard deviation, and then find like, what's the question? And then find the proportion of average city temperatures that are lower than that of Singapore's. So we could definitely do that. Um, so yeah, so actually let me do that then. So I'll go here, add a little thing here, and let me open this up. So I'm going to disregard, let's see, is there a white marker here? I'm just going to disregard this and this and copy that up and then paste that in here. So like, let me just pretend, that I start off with this and then I also start off with this data frame over here. And this is all I'm given. So I need to find the mean and the standard deviation, and I can do that by using the data frame, right? So this is what I'm gonna get. And then super easy to do this. I'll just do df and then target the data frame, target the column that I want, and then just do dot mean function, and that's going to give me the mean. So the one thing that I noticed practicing this yesterday is that in order for this to work, I actually need to round to the nearest whole number, right? So this is 20 point, let me run this from the beginning. Whoops. All right. So right now it's giving me 20.7 and the actual mean is 20.66. So not all random samples are going to be the same. Not all random samples are going to be as close to the actual mean. So it's not, you're not going to actually get the like exact answer, but this is really good just to, have the normal distribution so that you could just practice. But yeah. So this is a mean for this sample random data set. And then to get the standard deviation, it would just be the same thing, average city temperatures in May, and then get the standard deviation, and then run that. And so it should be pretty close to, right, 2, which is the standard deviation, which is exactly what it should be. And then let's see, and then after that, I can, solve my problem. So the question is, what proportion of average city temperatures are lower than that of Singapore's? So in order to fix that, I mean solve that, I'm going to do from scipy dot stats import norm. Um, why can't I spell? Okay. And then norm.cdf. And so what I'm doing right now is I'm using the normal CDF function. CDF stands for cumulative density function, and this takes in 3 parameters. It takes in the point of interest, which in this case is going to be 26. And then it takes in the mean and the standard deviation. So it's the point of interest, the mean, and the standard deviation. And so I can simply put in now these values here and just set them to their own variables and then just put that in here. So the log again would be the mean and the scale would be the standard deviation. And then the point of interest is whatever point we're trying to find the area below or above, and that would be 26. And so I'm going to put 26 in there, and CDF finds the area or the proportion below the point of interest at all times. So it's only going to give you the area um, to the left or lower than 26. And so if I run that, it's going to give me this answer, which should be pretty close to the answer that I'm going to get here, but not exactly close because, again, the mean is slightly different. If I were to just like run this again, it might change because, it's just random samples all the time. So let me run that and run that again. Oh, let me do this real quick. All right, let me run it again. So like outputs, scroll down. All right, so now like we have 20.73, whatever, whatever. All right, so it's not going to be exactly the same, but again, you can just do it by hand and just verify the answer. You don't really need Khan Academy. It's just to kind of show that there's endless possibilities, like endless normal distributions that you can do, and that like students could actually just solve from the start, which is pretty cool. So I'm going to do round. I'm going to set this equal to answer, and then do answer And then what should I do? Answer 4 decimal places, right? And that's going to be the answer. So essentially, according to this random sample, the proportion of average city temperatures that are lower than that of Singapore's is 0.9948, which is like 99.48% of average city temperatures are lower than that of Singapore's. So yeah, and if I were to put that in Khan Academy, it might give me like no, like a no and like a wrong answer, right? Because it's not exactly it. But if I were to just change this to what it actually is, which is 26.66, and then the standard deviation of 2, it's going to give me the right answer, which is 0.37 whatever. Are you kidding me? 20.66. Oh, so smart, sorry. All right, there we go. That makes much more sense. So it's not that much of a difference, but yeah, so that's it. So, again, some things to take into consideration. When doing this, you're not exactly going to get the exact mean and standard deviation from the problem because, again, you're taking a random sample from the normal distribution. And so those numbers might not, all sum up and then to give you like the exact mean because again it's a random sample and it's not all of the values from a normal distribution. And remember, a normal distribution is continuous, it's infinite. So at the end of the day, yes, it's going to be a mean of 20.66, but if you just take like 500 values out of like infinite numbers, it might not give you 20.66 as we saw here. Like it gave us like what, 20.7 something. So that's the case for that. And so it's not going to always going to be the exact same answer, but just to answer this question, you could always just do this and just put in, the actual values and it should give you the answer. But again, if the purpose is to have your students like learn from the beginning and try to figure out the mean and standard deviation by themselves, then this is the way to go. And obviously it's just using, this as a context. It doesn't actually have to be exactly the same. So essentially, if I were to move this back to how it was, mean and standard deviation, this answer is right in context of the random, what do you call it, the random sample that we took here. So yeah, that's it for today. Bye.